The next session talks about multi-orbit satellite networks, GEO-MEO-LEO integration. As global markets shift towards multi-orbit capability, integrated GEO, MEO, and LEO networks are emerging as a future of resilient, secure, and high-performance communications. This session explores orbit integration, intelligent routing, in-orbit computing, and policy frameworks, enabling next-generation connectivity. We have with us the Chair, Dr. B.K. Jain, Director-PMA in Space, the Moderator, Mr. Jairam, Partner COMSYS, Speakers, Mr. Deepak Tawri, Co-founder and CEO, Geminus Space, Mr. Aniruddh Kabbinale, Founder and CEO, Maargin, Mr. Jairam, Senior Director, Marketing, Hughes Communication. I request all the speakers to keep their remarks concise and within the allocated time. I now hand over the proceedings to the moderator. Thank you.
So, very good afternoon to all of you. Post-lunch session, we will try to make it as much as interesting as possible. And the onus is on our moderator. First of all, let me thank SIA to having organized such a nice panel discussion. And over the years, we are seeing that SIA has become, and especially the India Space Congress, has become a very good platform to have the discussions on the such emerging topics. And the multi-orbit concept is one of the prominently talked topics for the last 3 to 4 years. It looks very exciting, it appears very exciting when you say that if you are given the flexibility and freedom to use either geostationary or the NGSO, MEO, LEO, certainly you can have the all the stronger or strengths of these three orbits to your advantage. And when it comes to NGSO, certainly again it is, we have seen the lot of advantages which are shown in couple of constellations which are already operating for past 2 years. And so if you have the latency type of application, certainly no one can beat the MEO or LEO. And now even we are talking about VLEO. And even when it comes to the security related aspect, the spoofing and jamming, if you have to avoid and then make your system more resilient to the interference and such type of obstruction, intended obstruction, the NGSO constellation plays a vital role. And of course, this type of NGSO constellation has also paved the way for several new applications, and we know all of us, we are talking about D2D and the NT and IoT and so on. So this is what the technology which can provide you the advantage. And then when it comes to the geostationary, it has been a heritage satellite. We all of us have grown up seeing the varieties of application from the geostationary satellite. It continues to have its own strength and play a role, especially when it comes to the broadcasting and with a wider coverage. There is no one who can compete with the geostationary satellites, which has been its main strength right from the beginning. Simplicity of the ground stations and so on. All this looks good. If really you see only the positives, but are there any challenges? And that becomes very important, especially when you fuse all the three constellations. And if we see from the perspective of the service provider, the satellite operator and the regulator, these are the three main community which would play the role in the entire end-to-end SATCOM business or SATCOM services. Do we see that really it is everything is good, so good that the way it appears and looks? So take from the perspective of the satellite operator. Is it commercially viable for a satellite operator to have the segment and provide the space segment in the multi-orbit? Do have the GSO also as well as LEO or VLEO or MEO? Will it make the business sense for him? And similarly for the service provider, I think among all these three, satellite operator, service provider and the regulator, the service provider is at the best position, because as long as he gets all the advantages of this multi-orbit constellation, he can utilize. But again, he will look at from the viewpoint of whether it is commercially viable for him. So if he buys the capacity from the satellite operator, he will certainly look at that at what cost per bit or whatever the service which is going to provide to his end customer, is it viable for him? If it is not viable, he will simply forego the other type of orbit or constellation. So, and especially if he has to use a common ground station. Now whether that ground station or user segment is compatible to all orbit. So he will make his own business case for a particular application, a particular type of category of the users which he intends to serve. When it comes to the regulator becomes much more challenging. And especially when it comes to the security related issue, the interferences, spectrum, there are many things which a regulator has to look at. And especially now the NGSO constellation, when we talk about the inter-satellite link, which again, it has both the while at the same time it reduces the cost of the ground segment, and then helps in reducing the latency. At the same time, now it also becomes vulnerable for the security threat. That the data captivity which you want to have, we don't know whether it is really has the vulnerable point or not. So, and then the compatibility issue, the interferences issue. The same spectrum, the good point is the same spectrum is being used optimally by all the three orbits. If at all you are using the GSO or the GEO, MEO and the LEO. The same frequency spectrum, the same overlapping frequencies, overlapping coverage, and still you survive and you can produce the service. So from a spectrum viewpoint it is very good. But again from the regulatory viewpoint, if a regulator has to see the interference-free operations, can the number of multiple say NGSO constellation coexist? How many? What is the limit? Where is the limit? Whether the service level efficiency or the services which are given to be given to the users of that quality. So there are many things, many challenges. Now, and especially when it comes to the NGSO, again, we have seen only couple of constellations. Again, across the world, the countries are looking at the emergence of more and more constellation. Then we will have the practical experience in terms of the quality, in terms of the interferences, in terms of the cost per bit and the viability of the business. And more constellation, more number of satellites in a constellation. There are the talks about the space debris, and then there is a concern for the astronomy community and so on. So challenges are there, and we have seen whenever any new technology comes, there are always challenges, and it is good that the challenges are also overcome. And we are also hopeful as far as India is concerned. We being in a government, whether it is in space, be it Department of Telecommunication or MIB, we are very, very open and positive to embrace the new technology, adopt it. We have done recently, probably most of you are aware, the projection for the projected demand for the SATCOM capacity, and it's a huge capacity demand which exists for the next 5 years, and we are very keen to serve that and meet that requirement whichever way, whether it is NGSO, GSO, and whatever way it is possible. Government is committed to look at the adoption of these new technologies in a proactive manner, but at the same time without compromising the basic tenet security, safety, and the providing the spectrum, the interference-free services, complying to the national and international radio regulation. So with that, I hand it over to Jairam, and it is very good that this panel which we have selected here is a very diversified panel. We have the service provider Hughes, we have the space segment provider, and the moderator himself is a SATCOM veteran providing the various consultancies. So hopefully when we during this session we will touch upon the significant all the relevant aspect, including the business, commercial, and if possible the regulatory aspect also. Thank you very much for your patient listening.
Thank you very much indeed, Dr. Jain, and welcome to you all and to our panelists as well. My name is Jeremy Rose. I'm a partner in a consulting firm, satellite communications consulting firm based in London called COMSYS. We've been around for about 40 years. We do a lot of technical consulting, commercial market. We're running a satellite project for a government at the moment for a sovereign geostationary satellite, and we do a lot of work on expert witness work when things don't go right and there's dispute resolution. But enough of me, and let me just talk about the NGSO market and the way it's changed. I mean, NGSO has been around for at least 20 years. We worked on the Teledesic project 20 years ago, but of course things have changed very, very, very significantly in the last 5 years because the world knows that SpaceX is going to take over and Starlink is going to take over. And if you've been on airlines and have been complaining about the internet connection, people say, oh, the airline will, oh, we've got Starlink. It's going to be the panacea. Which it sort of is and it isn't. But then, of course, Dr. Jain, you mentioned all of the other issues we have to think about, whether it's launch capabilities of how to get the satellites up there, which, of course, for SpaceX and Starlink is perhaps less of a problem. And there's the debris issue, and then there's atmospheric and radio astronomy. But all of those issues, I think my panelists were going to be talking about rather than me waffling on. So let me go to each of them and say, give us perhaps 1 or 2 minutes to start, who you are, what your company does, and then we'll go into questions, and then we'll take audience questions during the panel as well. I personally like to have people interfering and interrupting as much as possible. I can always tell you to be quiet, but it makes it much more interactive. So, Jairam, do you want to start off?
Thanks, Jeremy. Very good afternoon to all. I am Jairam. I'm part of Hughes Communications India, and I have been part of Hughes for the past 25 years. And mine has been a true multi-band, multi-orbit journey. In fact, when I joined, it was purely extended C or inside C-band. Then we saw KU, KA, and now various LEO and NGSO constellations. It's been a tremendously enriching, exciting journey because fortunately, I've been handling products for the past 10, 12 years. So I get to play around with all these, create those offerings. So it's been quite exciting. And we have come far. And that is, while the advancement in technology has contributed to this, the role of regulators like IN-SPACE and DOT has been quite significant in bringing the ease of business, making it, and last but not least, the open skies policy, which has helped all of us to bring down the cost of capacity for VSATs or satellite, which in turn has helped us grow in the business. So I won't take much of your time in this introduction. The objective of our panel and personally mine would be to add value to all of you in the next 40-45 minutes. Thank you.
Aniruddh.
Hello everybody, this is Aniruddh. I come from Maargin. We are a year-old early stage startup. So we work in SATCOMs. We are set up with a mission to put up a constellation of satellites to provide communications and orbital compute as service. Like I said, we are in early stage, so we are a telecommunication and AI focused company. So we are building some of these components for optical communication, RF communication, and AI models for onboard computing, as well as something towards clustering these satellites to perform as a platform for computer service. So this is something we are working on. Yeah, mostly again, it's been a year for us into this journey. So LEO is something we have some thoughts on. I'll be happy to contribute more on how we think the design or the business should progress on multi-orbit front. Yeah, thank you.
Thank you. And Deepak?
Hi, good afternoon. I'm Deepak from Geminus. We build software products for space missions. Major focus is on the ground segment. We have built platforms and still work in progress to automate the management of ground segment infrastructure at scale, automate the operations, and also data pre-processing part. Thank you.
So let's just dive into questions. And the first one I wrote down here is, now that NGSO, non-geostationary, is viewed by many as taking over from geostationary services, which is debatable. Dr. Jain asked me at the beginning, he said that you sound like that you're not very pro-NGSO and you're an old GSO sort of guy. And the answer is, of course, yes and no. There's great advantages to geostationary. It gives you the ability to get capacity density, which I'll describe in a second, and then you've got advantages of NGSO as well. We've got lower latency. Lower latency, if it's required, is perhaps important, but for what percentage of the market is that important? But for us, capacity density is interesting because if you've got an NGSO system covering the entire globe, you can look at potential options for different orbital constellations, but the USA, for example, is 3% of the Earth's surface, so that means that if you've got 30 terabits capacity over the globe, you've got 1 terabit over the USA, which isn't so bad, but then you've got spots there which are going to be congested, and even Starlink is facing congestion in places like Africa and Nairobi at the moment. India is a little bit smaller, perhaps 1.5% of the Earth's surface. So if you've got an NGSO constellation being proposed for India, then 99% of the capacity is over somewhere else. Are you going to be throwing that away, or are you going to look at potential joint ventures with somebody else? But is NGSO going to take over from GSO? What are your thoughts about that? True or false, or a bit of both? Deepak?
Okay, I would not look at it like Spider-Man versus Superman question. So I think especially the LEO's satellites, they're definitely going to solve some of the use cases much more effectively than what geosatellites could. Of course, geosatellite has its advantage, as you mentioned, with the large area coverage, persistent coverage, and simpler ground stations. But for the low latency application, of course, the LEO satellites are much more reliable and more relevant. So I think depends on the use case. It will be, I believe, GEO, LEO, or mix of these two. Eventually, people will talk about not orbits, but service. Behind the scenes, combination of these orbits are giving or not, it doesn't matter. Thank you.
So, Aniruddh, I mean, are you looking particularly at NGSO or GSO as well?
No, we look into NGSO only specifically.
Right, so why did you say not GSO? Why did you go for GS and non-GSO?
I mean, of course, something that's coming up with low latency services. I mean, LEO will enable low latency services. So that's where we thought we should start off with NGSO. But that's not with the thought that GSO will go away and then NGSO will come. It's more about how do we bring in more applications, more services that can be provided with this NGSO setup, in addition to what GS is already doing. So that's the third. Yeah, to add on to some more thoughts on how NGSO and GSO can exist together. I don't think GSO would go away. Multi-orbit, of course, will help making either of these more resilient. For example, the life cycle of NGSO and GSO are quite different. So the deployment cycle we look at it as, our life cycle we look at it as probably 6 to 8 years compared to 15, 20 years of GSO. So this would actually help us see how during refilling or how when there are gaps in the constellation that's flying, how things can be alternated, or the services can be alternated across these orbits. So this is some thought from me, yeah.
So there's 2 points I want to sort of bring up on that. Latency. Everybody says, oh, low latency, that's a big driver. How? What? For who? How many people really want low latency? The people who are running gaming, the guys who are looking at HF trading. Is it really such a big deal?
I don't know if gaming is something that can be targeted with even LEO, but for anything that's interactive, say for example a video call or an audio call with quite a lot of interaction from both the sides. So that's where I think services can be enabled using LEO. Yeah, that's some of the service, at least most of the important services that can be enabled using LEO compared to what GEO already has, because the latencies there are significantly higher. But that doesn't mean anything saying that, for example, there are a lot of use cases, say IoT or bulk transfers or even backup. So these things will typically, should be definitely still possible with geostationary satellites. Yeah.
And on the life cycle side of things, I mean, it's an advantage and a disadvantage. I mean, it's an advantage because you can replace your satellites every 5 years. The disadvantage is cost. Is it as simple as that? I mean, there's two sides, or are there multiple issues involved?
I think it's twofold again. The life cycle again becomes, it's also sort of like, for example, when you take LEO constellation, typically you'll have more number of satellites, and then when you push, to have satellites as big and as qualified, space qualified as geosats into your LEO orbits won't make economical sense. So we do a lot of, take a frugal approach, or take an approach where you would be okay with putting them up for 6 to 8 years for a mission, and then, of course, a little smaller, economically cheaper satellites is something that will be a good direction to go for LEO.
Right. So Jairam, I mean, you've got skin in the game. In both senses of the word. You've got a geostationary platform, which is certainly in the USA is not doing so well in terms of subscribers because you're losing those to Starlink, but you've also got interest in the non-GSO side of things with OneWeb. I mean, what's your view on the dynamic between the two?
It's quite interesting, and that answer is not straightforward. There are two aspects, what we believe, and I am largely talking about India from an Indian perspective to start with. I would say what NGSOs and specifically LEO has done is rekindle the interest in satellite, which was, maybe 5 years back, there was a doomsday prediction about the satellite industry going down and no growth, etc., etc. Now, it has done two things. One is it has helped satellite go to areas or segments which was, unthinkable, like consumer. Now, I know it's one particular, maybe Starlink has taken the lead, but I think the upcoming LEO constellations are also focusing on consumer in a big way. Because where else do you sell multi-terabits of capacity? So that has pushed the envelope and helped bring satellite into mainstream, relatively. It is still a complementary service. It's not competing with terrestrial, but there is still a market for, or a group of customers who want satellite, cost-effective satellite, high-speed. Second, it has brought in the concept of very extremely high speed, 100 Mbps, 200 Mbps on satellite. And people are talking about like they're buying a broadband. That is quite unheard of, which was not possible in GEO till recently. It's still tough. On the other hand, it has helped GEO also. The operators have become smarter. They were forced to become smarter. And they come up with innovative models to bring down the cost of capacity so that they can retain and sell more to the core satellite VSAT, the core old VSAT customer base. The number of sites might have come down, but the average capacity bandwidth requirement per site has gone up. There's no doubt about it. And it is wherever VSAT is the only solution, whether it's a mobility, maritime, aviation, or defense, it is quite strong and it's growing. People are upgrading, in fact, defense is upgrading their GEO satellite captive networks, etc. And LEO can be an add-on. So what it has done is, it has had a, I would say, I know the satellite operators may not agree with me, but from a service provider's perspective, we are in a position to offer the best of everything in terms of cost, quality of service, experience to our customers, which will help grow the VSAT. I would say I'm calling NGSO, GSO, everything under satellite, the satellite industry.
Yeah, I would just like to make, and I think it is rightly the way it comes out. And you're right, alone latency, I don't think that really latency is a big deal. How many applications, how many really the users which would be looking for the latency. So, but apart from latency, and you see the basic advantage what I see in NGSO is the capacity. The capacity or the throughput which it provides, it has the ability because of the multiple number of satellite which are widely separated and then looking at towards the same area. Certainly you have the more spectrum reuse and you will be able to generate the more capacity. Of course, the same thing is now being possible through high throughput satellite in GSO with putting the multi-beams and the steerable beams. But even then, the sheer number of satellites which are visible at a time from one location, it still has the age. That is number one. But number two, at the same time, the cost which you have rightly brought out, is it really provides the cost per bit? Until unless you are able to reach out to the other areas, other than what is your intended service area, because by inherently it is a global coverage. Until unless you are able to market the capacity and take the advantage of the entire global coverage, this will never be the cost viable, and the cost per bit, which what service provider needs, it will not get. But then again, it depends on the business case, country to country, and the other things. So I think both have to be there. GSO has its own role if you want to confine the coverage to your country or a particular specific area and want to give the entire capacity and generate high throughput capacity. It is certainly possible from the GSO itself at probably the lower cost as compared to the LEO if you are not able to market it to the entire globe.
So, thank you very much indeed, Dr. Jain. But any audience questions at the moment? Any people want to try and steer the conversation towards a specific area? Or is it the post-lunch? Oh, yes, okay, the gentleman at the front here.
The question of the orbital space, the launch of so many satellites all over, even LEO is getting overcrowded, they say, and now we're going into VLEO. So what's your take on that? You're talking of non-GSO, but the overcrowding of this thing, so you have the space policy, you have the space law, the outer space treaty and all. So what are your views on the overcrowding of even the LEO, and now we're getting into VLEO, which actually was not mentioned? Thank you.
Well, actually, VLEO was mentioned by the chairman right at the beginning, but it's an interesting one. So, yes, PK, Dr. Jain, do you want to deal with the overcrowding issue?
This is rightly you have touched upon. The space is getting crowded because of these constellations. It's a fact. And now you really don't have the if you have to use the same frequency band, probably now you will not get the suitable orbital parameters to coexist with the already existing services. So people have now started looking for the different orbital heights, going for the VLEO. Of course, VLEO has some more advantages in terms of giving you good resolution, good capacity, the power margins, and more resilient link and all. But the VLEO has its own drawback and challenges in terms of maintaining them because of the gravitational force. It requires better maneuvering and more fuel. The orbital life would reduce. It has its own thing. So it's again emerging thing. We are yet to see. It still is in the technology demonstration phase, whether VLEO would be successful, and especially it will pose much more problem when you have to really avoid the collision and then going for a new launches and all that thing.
I don't want to get involved too much in a discussion on VLEO, but just to ask, what's the big deal about VLEO? Isn't LEO good enough? I mean, if you're talking about VLEO, then you're starting talking about problems with atomic oxygen and creating problems for yourself. What's the big deal for VLEO?
No, there's nothing big deal about it. What I mean to say, like what Mr. Jain said, the overcrowding of LEO, I'm sure that's why we're going to VLEO, right? We're coming down and down and down because there's no orbital space for the launch satellite, number of satellites getting launched, the frequency at which. So that's why I just wanted to raise this query. So nothing great about, but since LEO is getting overcrowded, so VLEO, and what's next, what I meant was, unless you have mechanism to really, put a bind, okay, this much country, this many satellites and all, something like that. Yeah.
Thank you. So yes, we'll take one more question over here, and we'll go back to the list I prepared.
Hi, good afternoon all. My question is with respect to inter-satellite link. Though it is addressing the technical aspect of reduced number of gateways at the ground station, but parallelly it is creating a security risk for our regulator to address. So how industry is looking to address that aspect? Thanks.
Aniruddh, do you want to take that one? Space segment man.
Sure, I can take that one. At Maargin we work on optical inter-satellite links as well. Optical, again, one primary reason is to address security. That's one primary way how we think we should address security. I mean, unless you really go align the transmitter and the receiver aligned to each other, there is very significantly less probable chance of you being attacked. So that's one approach we have taken. RF, probably there may be measures we may need to take going further, but this is optical inherently comes with such a aspect where security is dealt with. And again, so more with security, I think there has been some more directions of work where optical communications can enable higher security apart from whatever RF can provide. So even considering a network, let's say for example, optical links currently are between your set of satellites, so you again decide how to route them. So that's something again ensures your security as well. Yeah.
Deepak, do you want to address that?
Yeah, I think it's, if you look at the industry and the terrestrial network, the normal IT world, how the security challenges have been faced, how they've been sorted out. A similar pattern, I believe, would be seen in the space. Hardware, software, more innovation for security measures will be done, and also a lot of coordination and monitoring from the ground segment. That's what will play a big role in making sure that assets in the space are secure. Thank you.
Yeah, Jairam.
I think this is with specific to the inter-satellite links. Every technology has its pros and cons. Now, inter-satellite link actually helps you to increase the capacity and, as I said, reduce the ground structure. But at the same time, the security aspect cannot be overlooked. So it has to be a balance between both. And I think that is the crux of what is being discussed today. And I think on the security clearance, that is a discussion which is happening today with the regulators. I think it's important to strike that balance. Nobody would like to have system which has been, which is suboptimal, but at the same time, the data sovereignty and the national security cannot be compromised. So it is not just about India. It is a question being asked everywhere, and I think it will continue to go on. But I believe in the later generation of LEO constellations, this will definitely be addressed, because it is a global phenomenon. It is not a local phenomenon that some countries are demanding for it. Everyone is demanding for it. And some of the incidents that we have seen over the globe, I mean, in the recent past, has actually necessitated a need for it. It helps everyone, each and every country from that perspective. And it makes easier for a global constellation like LEO or MEO to be accepted by each and every country.
So I think that might lead us on to a related issue of resilience and national and critical infrastructure. Certainly the word that we hadn't really heard until about 2-3 years ago, which was sovereignty, is an issue relating to resilience and critical infrastructure. To what extent do you think that's the savior of the satellite market, that people are thinking we don't want to go with Mr. Starlink because he might change his mind tomorrow and cut us off? We want to have our own independent infrastructure. To what extent do you think that that's going to be something, and we've seen that with the project we're working on at the moment, with other projects that we would like to work on, where the business case is perhaps not so much as important as the resilience and the ability to say, look, we're in control of our own network. And then, of course, from the non-GSO, that relates to how do you provide services in other areas of the world, and the gateway issues too. So do you want to look at that one, Deepak?
Let me understand the question. It's about sovereign versus non-sovereign assets.
I think it's more about resilience rather than...
Okay.
Yeah.
So resiliency, I mean, if I had to compare GEO versus LEO constellation, resiliency point of view, depends what we are trying to survive here. The satellite failures, of course, GEO becomes single point of failure. But the large scale LEO constellation, they are like a few satellites go here and there. I think it still is going to be resilient. I think that the other aspect you touched upon is the sovereign. Every nation would like to have their own Starlink equivalent or Starlink kind of infrastructure for their own nation. That becomes a big challenge. I don't know with the amount of number of satellites that will be in the orbit, how that will be possible, and how the international laws and regulations are going to control that. Thank you.
So the geostationary satellite is a single point of failure, but it's 35,000 kilometers away. On the other hand, the non-GSO guys, you've got a LEO, they're much, much closer. They're easier to get to physically, but there's hundreds or thousands of them. So I think it's swings and roundabouts.
Yeah, and also, like, if you look at from security point of view also, the attack surface is much larger, you can say, for LEO satellites, but the effect of targeting few satellites is not that much. So resiliency point of view, if I had to compare, I lean towards more of large-scale LEO constellation because a lot of redundancy is built into that. Thanks.
Jairam?
Yeah, it's a interesting and complicated question, and I got a slightly long-winding answer for this, because I would like to see this as specific to different customer segments, rather than as a one single answer which is true for everyone. For example, let's look at defense. Their resilience and data sovereignty go hand in hand. So GEO is going to be there, and of course that particular network will get upgraded. But at the same time, LEO can be used for non-critical applications too. They need high speed for border surveillance, high speed mobility. Definitely LEO will be come as a add-on layer till the time the defense forces are satisfied with the security aspect or the sovereignty aspect. When it comes to, let's say, maritime has already adopted a LEO-GEO kind of what you call construct, because LEO is not available in certain geographic regions for geopolitical reasons. So they cannot do away without GEO. Although there are many vessels going on a dual LEO, but still the same problem persists. It could be regional. So there again, multi-orbit is a necessity rather than a choice. Third comes, let's say, digital divide projects. Now, I mean, in the morning panel, there was a discussion on how 6% of the country is still not connected. Mr. Satya did talk about so many villages not having cell backhauls, etc. But if we have done this analysis quite, I mean, if you look at deeply, these are big pockets, like for example, Northeast, the hilly regions. You will need maximum capacities in those regions. Now, Jeremy, you alluded to the capacity of a LEO. Now, capacity of LEO, you say TBPS, but then there are cells. There are limitations of the capacity in each area. So let's say Arunachal Pradesh needs multi-terabit capacity. No, not a single LEO may be able to cater to that. So we'll need LEO and GEO. So when it comes to school, now schools have two use cases. One is a broadband. I would say a low-cost LEO is an answer to that. But schools also need this content delivery services, and there is nothing yet to beat a multicast of a GEO. So they will coexist. They may coexist and likely to coexist. When it comes to consumer, I don't think GEO has a chance, at least in the foreseeable future. It has to be LEO, a low-cost LEO. When it comes to enterprise branch, it will be a LEO, because there is today, that is in India, I mean, largely it is dominated by terrestrial as a broadband or an MPLS or a 4G or 5G. So LEO can act as a backup, like with the best of, I would say, the quality of experience of terrestrial and the reliability of satellite. So I would say this resilience, sovereignty is, of course, it's underlying concept, because that is the entry point for any constellation. Without that, no regulatory body will allow a particular constellation to come in. After that, resilience is defined by the segment and the reality of that segment in terms of connectivity.
I think you have touched upon a very pertinent point, Jairam. When it comes to the sovereign, that is very critical. And you have rightly said that all critical infrastructure should not be dependent upon the non-sovereign constellation. That is what I understand, that which you brought the point. It's a true power sector, the energy sector, the stock exchanges, all the critical thing, apart from the strategic sector. They have to be as far as possible on the sovereign country, so that a non-sovereign constellation denies the capacity or the services in the critical moment. The entire thing should not come to the standstill. So I think that point is well made.
So you've opened that can of worms, I think, because India was always viewed as being restrictive, and we see now, for good reasons, because there's the sovereignty issue. Do you think that's going to affect your position over the coming years in terms of other networks providing services in India, or are you going to be concentrating on national infrastructure criticality just for India?
So, that I think Jairam has already answered. See, as far as non-critical services are there, of course you can use, and the capacity is being used, and you can have any type of the SATCOM capacity which is available and which can serve the need. When it comes to the critical thing and all, probably already India has its own satellites, Indian satellites, and they are serving the country's need.
Yes.
I would just like to add, especially for defense use cases, the needs are quite this wide spectrum, whether tactical low latency communication, sorry.
No, go on, I was just...
versus persistent coverage and communication. So definitely defense, they would definitely, the multi-orbit use case makes a lot of sense. And if it is for defense, the sovereign assets is the only option India has. Thank you.
So we're running, I think we've got about 10 minutes to go. Yes, okay. So looking specifically at India again, which applications are likely to be the first major adopters of multi-orbit architectures? And I've written down here, enterprise, government, defense, mobility, cellular backhaul, maritime, aviation, rural broadband. I haven't included baking, but everything else is in there as well. Do you have a feel, Aniruddh, as to which are going to be the first adopters?
Yeah, I'll quickly bring some context from the previous question and then add something here. Technical direction of resilience. So when you have two such connections, one from GEO as well as from an NGSO setup, so it's more like if you have an integrated terminal, so it's more resilient by default in technical aspect. So with this perspective in thought, I think defense and critical sectors, government agencies, etc., would be primarily interested in such a multi-orbit connectivity primarily. I don't see a reason why enterprises, anyways, this is a backup connectivity or sort of enhanced connectivity that is being provided to the enterprises or maritime or aviation, so that they would also come in. So that's the order I would think industry will come in. Yeah.
Yeah, Jairam.
Hi, so I had alluded to this in my response earlier, but the sure shot segments which we feel will go for multi-orbiter defense, maritime, aviation, especially when you're talking about the international routes, because they always look for a multi-orbit solution because they don't want to be left high and dry in certain area because we're going over China, Russia, you may not get a airspace, you may not get a LEO today. So when it comes to digital divide projects, because of the sheer necessity for large capacity, both will coexist. It need not necessarily be for resilience, but for from the practical perspective, you will need both. Enterprise branch, I'm talking about branch access, I don't think will be a great use case for multi-orbit. But when it comes to data center backup, I would say a backup to critical assets like a refinery or a factory, definitely multi-orbit will be in the play.
So, any other questions from the audience? If there's one, yes, there's one gentleman there. We'll take a couple of questions, then I've got an awkward question to ask at the end.
Thank you. All the discussions that we are hearing are about GEO and LEO. So is MEO become totally irrelevant? That's what my question would be to the panel.
I'm sorry, could you repeat that again?
Are MEOs becoming irrelevant? The medium Earth orbit satellites, have they become irrelevant?
Interesting question, yes. Are MEOs becoming irrelevant? Well, you're the MEO man, Jairam, I think. It's OneWeb, well, OneWeb is LEO, but...
No. MEO is not irrelevant. MEO is, when I mentioned LEO, I meant NGSO. I mean, MEO has specific use cases as in the current avatar or current form that we see MEO. Definitely it is good for those use cases where you need multi-100 or Gbps kind of capacity dropped into one area. Definitely MEO is the best solution, I would say, possible, more than a LEO or a GEO. A lot of cruises are using MEO, wherein they need multi-Gbps capacity to satisfy the customer requirement. Like, for example, one example in India would be, let's say, you want to drop multi-Gbps bandwidth to an island in Andaman and Nicobar, for instance. MEO would be the right bet for that.
So why is it only, I think, mPOWER that's gone with MEO? Everybody else is going with LEO. I mean, MEO is cheaper in terms of the number of satellites, so why the big thing about LEO?
First of all, I would say the number of satellites required to cover the entire globe is low. That is one. I think the biggest challenge for MEO would be not the latency. Latency is much better than GEO, although lower than LEO.
Yeah.
Is the cost of the ground, that terminal. I think that actually has the limitation. Once they crack that code of bringing down the cost of the terminal, I believe MEO would also be as relevant as LEO.
So we've got a question from the gentleman over there, and then we're going to wrap up.
Sorry, I have a little different opinion what you are discussing. There are multiple problems when we talk about the integration GEO, MEO, and LEO satellites. You see, one of the simple problem is unequal Doppler shift of the frequency. That's why what we are working, I mean, in a team with the NASA, is can we have a GEO node? Can we have a MEO node and LEO node and then establish the communication? And I would request you to throw some light on the protocol, but that's more important. Because LEO works on a different protocol. I mean, the Chinese satellites work on a different protocol. NASA works on a different protocol. ISRO has different protocol. So it's a very difficult problem that all of them will communicate. Could you throw some light on that?
I think from the point of view, the answer is yes. And when there's a technical question about Doppler, it's just a technical question and it's soluble. But Deepak, you were quite keen to butt in there.
Yeah. So I'll not go too much into technical depth of Doppler effect, but the communication between GEO, LEO, I mean, it was successfully proven as old as like 1983 with the STS-8 mission to relay commanding and data. Definitely, these three layers of orbits need to be integrated. The critical thing is, I think we should touch upon that also, the software and AI-based automation, especially on the ground segment side, need to integrate all of this. If I had to give some simple analogy, some kind of like what Uber has done for cars to manage thousands of cars, and much more sophisticated way, some ground segment management plane has to orchestrate, manage satellites across multiple orbits. Also need to give kind of a seamless integration of all these three orbits to provide common service experience. That will be the key thing, and that's from the end user point of view, I can say. Thank you.
If I may add, because we got experience of having a GEO and LEO working, we've done multiple POCs in the country in the last few months. Ultimately, it all boils down to the IP level. Now, what we are usually doing is bifurcating the different applications. For example, there are certain applications which are latency sensitive. We put it onto LEO, and so we look at active I would say configuration for LEO GEO, and is controlled by an SD-WAN. Now, SD-WAN is that layer, orchestration layer that Deepak mentioned. That is the layer which will bring in. I mean, that's where a managed service layer comes into the picture. I mean, that's where service providers like us bring in our value. And for customer, it is seamless. So when one link goes down, the other link takes over. That's an auto failover configuration. So that's how generally we book it. So we look at it from the IP level. I mean, at the constellation level, we don't have a control. So that has worked well so far. And that's how it's going to continue. So today we have a multi-transport configuration wherein it could be LEO, broadband, and LTE because the latencies are similar. Then we have a multi-band or a multi-orbit when it's LEO and GEO or LEO, GEO, MEO. So all this is possible with that orchestration through an SD-WAN or a similar managed device.
So 5-second answer. If I'm going to, well, Dr. Jain, I'm going to ask you the question because you picked up the microphone. In 5-10 years' time, which NGO systems are going to be around conquering the world? 5-second answer.
There could be multiple.
Okay, right, Jairam.
Same. In fact, today we are two active. There are a third coming up, and there are multiple others. I can't even name, including Chinese and Chinese. So multiple LEO constellation. It could be fragmented, but at the same time, I would say the LEO constellation, which reinvents itself continuously, will have an edge. And upcoming LEO constellations, they'll be forced to bring in their own USPs. Because there has to be a differentiator. Cost alone cannot be a differentiator.
That was 18 seconds. Okay. Aniruddh, 5-second answer. Which ones are going to be the successful ones?
Yeah, I think again, economics may be one huge front, given that the life cycle is not as long as whatever GSO has. So I think whoever works on economics and then starts providing services and still can sustain over one life cycle, probably I think will continue to remain. Again, sovereignty can be one more aspect where a lot of things can continue to operate. Like say, for example, India may have its own constellation for communication, or any other country for that matter. Yeah, thanks.
Deepak.
Yeah, we'll see more and more LEO constellation from many vendors, many nations. But I believe the future is like coexistence of multi-orbit satellites. And the key thing is the management. Key thing is how we are optimally orchestrating the resources across multiple orbits. That will be the key thing that will define the future of multi-orbit satellites future.
Gentlemen, thank you very much indeed for all of your inputs. Thank you, ladies and gentlemen, for your participation. And thank you to SIA for organising such an amazing conference.
Thank you for a highly insightful session. I request all the dignitaries to please come in front for a photograph. Please give a huge round of applause for our distinguished panel.